Hey, what's up? I'm Maywell, checking in with the first science on a need-to-know basis. Each installment's going to cover the latest science news and other intel that you won't find at larger media sources. Over the past month, the Joint Quantum Institute held a non-official vote for the winner of this year's Nobel Prize for Physics, and the results show three front-runners: quantum entanglement, quantum non-locality, and particle discoveries. The poll showed people think quantum information will win, which includes work on qubits, quantum data processing, and quantum state teleportation. The second place was a tie, one for work done in the 70s and 80s on quantum non-locality. The other second place winner was for the discoveries of the top quark, bottom quark, and the apparent discovery of the Higgs boson. Fourth place was the achievement of slowed and stopped light. In the end, we'll know for sure who won next week on October 9th. Next, a team of scientists has been able to directly derive and measure the photoelectric current generated by single molecules of the photosystem 1. A long sought-after achievement, a method to measure photocurrents of a single functionalized photosynthetic protein system was developed by a team of scientists from the Technical University of Munich and Tel Aviv University. The chloroplast proteins they developed represent light-driven, highly efficient single-molecule electron pumps that can act as current generators in nanoscale electric circuits. They call it Photosystem 1, and it could be the first step on the path toward harnessing photosynthesis for practical energy. Georgia Tech has shown that the immune system can be enhanced to help regenerate peripheral nerves. Macrophages are specialized cells that help in your autoimmune defenses. They attack infection, clear dead tissue, and, according to Georgia Tech, can help conduct how the healing process proceeds. What happens is, after some cases of injury, scarring can prevent nerve regeneration. But scientists discovered that by targeting macrophages with a drug called interleukin-4, or IL-4, the immune system could be coaxed into regenerating the nerve. Research is now underway to fine-tune the process. A Japanese study has shown that those motivational posters around the workplace we all know and love actually help sharpen worker focus. A further study is planned to determine whether or not this is good news or bad news. Ordinary plastic has been found to have electromagnetic cloaking properties. Electromagnetic cloaking was once only thought capable with complex devices or expensive metamaterials with electromagnetic cancellation. But now, researchers have found that plastic decreases electromagnetic scattering. Unfortunately, this doesn't mean you become invisible when you put a grocery bag on your head. Only electromagnetic radiation at microwave frequencies become obscured. In a first, researchers at the Stanford Synchrotron Radiation Light Source Laboratory have created a therapeutic protein that was designed using a computational model. Typically, researchers begin work based on observations of natural activity. The University of Washington pitched in supercomputer-grade computing power to help them analyze over 800 natural proteins and determine which best interact with target proteins that become infected with flu viruses. They identified two that block the replication of both flu and H1N1. SSRL was also able to show that the way the two designed proteins bind with Spanish flu protein were virtually indistinguishable from those designed in the computer, providing crucial atomic level validation for the computational method employed. A team of researchers from the James Hutton Institute and the University of Alberta, Dundee, developed a type of soil that allows roots to be studied by the eye. And it's just cool. Transparent soil could be used in crop genetics to promote growth of more efficient root systems that rely on less fertilizer. Physiologists could also use transparent soils to understand how plants or microbes access nutrients from soil. It's made of a synthetic compound known as naphthalene, which is used in power-generating fuel cells. It's not exactly transparent until water-based solution is applied. They say it's actually very similar to real soil physically and biologically, and it's pretty cool. Well, we know in a while that there are these little hairs inside the inner ear that relay auditory information to be processed into audible sound. These hairs, called stereocilia, sway back and forth when they detect sound waves. A collaboration at the Bayer College of Medicine found that the stereocilia also literally change in length upon sound wave detection. I'm going to go totally out on a limb and make an armchair guess that this relays the loudness information to the inner ear. Loud would cause the hair to retract, and as we age, the ability to extend the hair diminishes, causing hearing loss, but that's just my take. YouTube and Xbox are planning to stream the presidents live, giving eager voters another venue to watch the candidates not answer questions. And the last story today is probably the biggest news for eyesight since LASIK. New York SUNY has developed specialty